The quadratic formula is a way that always works for factoring quadratics. It's not always the fastest way, but it does always yield solutions for the quadratic formula, and sometimes no solution. So it's pretty easy to remember if you think of the song Pop Goes the Weasel. So, all around the cobbler's bench the monkey chased the weasel. The monkey thought it all in fun till pop goes the weasel. Now we're going to put a little twist on that song. And it goes, x equals negative b plus or minus square root b squared minus 4ac on top of 2a. Alright, you try it with me. X equals negative b plus or minus square root b squared minus 4ac on top of 2a. Alright, let's do an example question now and apply what we just learned. So x squared minus 8x plus 12 equals 0. Notice this has to be equal to 0 for this formula to work. If it's not equal to 0, you need to make it equal to 0. So it's as simple as ABC. So we have A, B, and C. A stands for the coefficient of my x squared term, and which is 1. B stands for my coefficient of my middle term, or the x term, which is negative 8. And C is for my constant, which is 12. So it's just ABC, and then we just plug it in to the formula. So x equals, and then if it's a negative b, we already had a negative 8. So that's going to make that a positive 8. If you negate a negative, it's a positive. And then plus or minus. The reason we have a plus or minus is because there's going to be two solutions. So, or in most cases. And that's square root of b squared, so that's negative 8 squared. I'm going to put that in parentheses. And anytime I square something, it's going to be positive. Next up is minus 4. My a is 1. So I plug in 1 in parentheses, and my c is 12. So I put a 12 in parentheses. And it's all written over 2a. So 2a is 2 times 1. And I'm going to follow order of operations when I do that. So I'm going to simplify my square root. And I have an exponent in there, and I have multiplication. So I'm going to do the exponent first, and then my multiplication. And then I'm going to subtract. So I'm following PEMDAS. So let's simplify that. 8 plus or minus. Ran out of room, so I'm writing it up here. And then square root of negative 8 times negative 8 is going to give me 64. And then minus 4 times 1 times 12. I do all that multiplication first, and I get 48. And if you were subtracting a number that's bigger than that first number, my 64, then you'd have a negative square root. You can't have a negative square root, so there would be no solution in that case. But here we're going to have a solution, because it's going to be a positive square root. And 2 times 1 is 2. And I'm just going to simplify that out. 64 minus 48 is going to give me 16, so it's really 8 plus or minus the square root of 16 over 2. And this is where the plus or minus comes in. We're going to have two solutions. An instance where you would only have one solution is if your square root was of 0. Then it wouldn't matter if you added or subtracted 0. It wouldn't change your value. But here we are going to have two different solutions. So 8 plus 4, and I just did square root of 16 is 4, over 2. And we have 8 minus 4 over 2. And I treat the top like it's in parentheses, so we always reduce the top and the bottom first before we divide on our fraction. So 8 plus 4 is 12. 12 divided by 2 is 6. 8 minus 4 is 4. 4 divided by 2 is 2. So my two solutions are x equals 6 and x equals 2. Alright, let's try a little harder example for example 2. Remember, on a quadratic formula we have to set it equal to 0. That's very important. And on example 2 you can see that's not the case. So you have a choice. You can move everything on the right over to the left, or you move everything on the left over to the right. It really doesn't make any difference. You're still going to get the right answer. So I'm going to move everything from the left-hand side. Actually, I'm going to move everything from the right over to the left. So negative 6x squared, the inverse is a plus 6x squared. Whatever I do to one side, I do to the other. Notice I'm just adding that 6x squared to my like term, to the x squared term. And then that cancels these, because that makes it 0. And then a plus 7, how can we cancel a plus 7 if we put a minus 7? Whatever you do to one side, do to the other. Notice I put the minus 7 off to the right of that 3x. That's because it's not a like term with my x term there. So it's kind of going to be hanging all by itself. So 7 minus 7 is 0. So on the right side I just have 0. On the left side, 4x squared plus 6x squared is 10x squared. And my minus 3x doesn't buddy up with anybody. Neither does the minus 7. So I just leave them as they are, bring them down. And now I just have my A and my B and my C. Remember, it's just as easy as A, B, C if you have them written in order. So the x squared term always comes first, the x term's always in the middle, and then your constant always goes at the end. So A is going to be 10, B is negative 3, and C is negative 7. And now I can just plug those in just like we did before into the quadratic formula. Thanks for watching. Actually, I just got to thinking there's one more thing I wanted to show you. Let's say you had the quadratic formula simplified to this step, and you had 24 minus 80 in the square root. That's just an example where you could have a negative square root, and that would be negative 56. And that's what I was talking about. If you have a negative square root, we would just say there is absolutely no solution there. The only solution you would have would be imaginary. So if we were to graph that quadratic, it means that that quadratic is never going to touch the x-axis. And really, when we're solving for x, we're just finding where does the graph touch the x-axis. And this would be an example where it never does. And this would be another one where it never does. So those would both have negative square roots when you do the quadratic formula, and it would never touch the x-axis. Here's an example where you would have exactly one solution if it only touches it once. And then here's an example where you would have two solutions where it touches it twice. Like here it would be right here, and that one would just have one solution. Thanks for watching.